Pritham, please unmute yourself and tell me screen is visible.
Yes, sir.
Okay. Good morning, everybody.
Screen is visible.
Lakshmi, see, here you have two diagrams. The same type of component you have to produce in machine shop. See here, there will be two dimensions, plus or minus 0.15 like this. Maximum dimension is 25.3 and minimum dimension is 24.7. See, for the diameter, first diameter and the length. Here, only for the length of the workpiece, they have mentioned upper limit and lower limit, not for the diameter. Suppose if while machining this component in lathe, if I have the dimension 40.15 or 39.85, then you accept the component. Otherwise, directly reject the component. Only two criteria. One is accept, other one is reject. The same type of component you have to produce in machine shop by using lathe. You understand the process of marking and all those things. Usually, the diameter of the shaft you have to produce in the component is 25 millimeter. Actually, the raw material has 27 millimeter. Then you have to remove 2 millimeters metal, and afterwards you have to mark the dimension on the workpiece. Then you carry out the machining operation by using lathe. Same way, you have to produce the component in machine shop. Next here, come here. Say this is one of the component. You can produce this component by using shaper or milling machine. Here also, there will be two dimensions, plus or minus 0.5 and 35 plus 0.8, 20 plus 0.5. So like this. To add the 0.5 to this dimension, that becomes 25.05. If you deduct this dimension, 0.5 lower limit from this dimension, it becomes 24.95. There will be two dimensions. One is upper limit, other one is lower limit. So totally calculate the total tolerance. What is the definition of tolerance? Tolerance is the difference between the upper limit and the lower limit. So here, the total tolerance 0.15 and 0.15. So that becomes 0.3. 25.3 or 24.97. You can accept the component. The name, accumulation of tolerances. Say, for each and every dimension, there will be a tolerance. That is upper limit and lower limit. Add all the tolerances and becomes total tolerance. That is the accumulation of tolerance for component A and component B. Next, come to the point. All of you, please write down the question. Please, all of you, write down the question. I told you earlier, please, all of you keep 200 pages king size notebook and pen along with the mobile or laptop. Please write down the question. Most of the question paper, you have a question on compound tolerance. You have a question on compound tolerance. Most of the question paper, if you collect previous 4 question paper, in that 3 question paper, you can find the compound tolerance question. This is very, very important. Examination point of view, this is very, very important. Please, all of you, write down the question. Explain briefly with neat sketch explain briefly with neat sketch the compound tolerance. Compound tolerance. Mark it very, very important. You can expect this question this time. See, all of you observe here. Here you have three dimensions. One is a height h, length d, and the angle theta. Angle theta. Suppose you need to measure this type of component in the machine shop. For height, upper limit plus c, minor upper limit plus c, lower limit minus d. And the width or length, upper limit plus a, lower limit minus b. Minus
ಸರ್
b.
ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಸ್ಟೂಡೆಂಟ್ಸ್ ಜಾಯ್ನ್ ಆಗ್ತಾರಂತೆ.
ಬೇಗ ಜಾಯ್ನ್ ಆಗಕ್ಕೇನಮ್ಮ.
ಎಸ್ ಸರ್.
ಮತ್ತೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ, ಬೇಗ ಜಾಯ್ನ್ ಆಗಕ್ಕಿಲ್ಲ. Those who are came late, please observe here. Here you have two components, A and B. Little bit difference in the diagram. You have to machine the same type of components in machine shop. Here, the very important thing is each and every portion of the component, they mention tolerance, upper limit and lower limit. So first you consider diagram A, the length is 65 along with the upper limit 0.15 plus 0.15, lower limit minus 0.15. Suppose if you add the upper limit to this dimension, then it becomes 65.15. If you deduct this lower limit from this dimension, then it becomes 64.85. So while machining, you cannot produce exactly 65 millimeter length. There may be higher, there may be lower. If the dimension is 65.15 or 64.85, then you accept the component or reject the component. Only two criteria. One is accept, other one is reject. The same way, you have to machine the component. So in our machine shop, this time we provide you the 27 millimeter diameter raw material. In that, you have to remove 2 millimeter material After that, you have to mark the dimension on the component, then carry out the machining operation by using lathe. Then for each and every dimension, you have the upper limit and lower limit. If you add these two, upper limit and lower limit, that becomes total tolerance. Total tolerance. What is the definition of tolerance? Tolerance is defined as the difference between the upper limit and the lower limit. Upper limit and the lower limit. Last class, I told you, tolerance is the positive quantitative number. For that reason, in definition, we are using the difference between the upper limit and the lower limit. Here, a dimension along with the upper limit and lower limit. If you add these two, upper limit and lower limit, that becomes total tolerance of 25 plus 0.3. That is the total tolerance. In the same way, you have component B. This component can be produced by using shaper and milling machine. Shaper and milling machine. Here you have three dimensions: 25, 35, and 20. So for all the three dimensions, you have upper limit, lower limit. If you add the tolerances 0.5, 0.8, and 0.5 again, that becomes total tolerance 1.8. Total tolerance 1.8 millimeter. This is known as accumulation of tolerances on the component. Accumulation of tolerances on the component. So these two are very, very important for mechanical engineers. If you go to any manufacturing industry for interview, suppose they give you the diagram like this and ask you to explain the total tolerance and the upper limit, lower limit, and what is the criteria you are using for the component. If the dimension satisfies the upper limit or satisfies the lower limit or between the upper limit and lower limit, then you accept the component or reject the component. This is very, very important. Anybody, if you go to any interview abroad, particularly in Saudi Arabia, Dubai, Gulf countries, they ask you the same question, the same type of question. Once 20 years back, I went to interview in Chennai. They asked me to explain the tolerance, upper limit, lower limit, and other criteria of the component, the same type of component. They asked me to show the upper limit and lower limit and measure the diameter and length by using vernier caliper, scale, micrometer, and all those things. So in the interview, they ask you the same thing. If you go to interview at foreign companies, if they manufacture the components. So this is very, very important for mechanical engineers, the tolerance and limits. Next, come to the point. If you collect previous 4 question papers, in 3 question papers, you find a question on compound tolerance. Please, all of you, write down the question. Please, those who are came late, those who are joined late, please write down the question. Explain briefly with the neat sketch compound tolerance. Compound tolerance. This question carries 5 marks. Please, all of you, write down the question. Explain briefly with neat sketch compound tolerance. All of you, observe here. The height h, upper limit is plus c, lower limit is minus d, and the width or length, upper limit plus a, lower limit minus b, the angle, the upper limit angle plus alpha, lower limit angle minus beta. Remember, while machining, if you consider the upper limit and the lower limit of the h, and if you, while machining dimension d, if you consider upper limit plus a and minus b, and while machining, if you provide the angle, upper limit angle plus alpha, lower limit angle minus beta, if you provide the upper limit, lower limit, and the angle in the component, all of you observe here, this is very, very important. Automatically, you will get L, uppercase letter L. No need to see the dimension of uppercase letter L in this diagram. If you meshing the H with the upper limit plus C minus D, and with the dimension D, upper limit plus A, lower limit minus B, and the angle, upper limit angle plus alpha, lower limit angle minus beta. If you consider all the three dimensions along with the upper limit and lower limit, automatically you will get length L. Automatically length L. No need to specify the limits for the dimension letter L. The dimension letter L. This is known as compound tolerance. The name itself indicates compound, adding the tolerance. Adding the tolerance. This is very, very important examination point of view. This is very, very important. Please, all of you mark it. Very, very important. You can expect this question this time. If you add the dimension h plus c and h minus d, same way d plus a, d minus b, theta plus alpha, theta minus beta. While machining, if you consider upper limit and lower limit for these three dimensions, automatically you will get length L. Next, come to the point, very, very important, limits of size and tolerance. Limits of size and tolerance. Say limits of size and tolerance. Say I ask you to measure the diameter of the shaft. You have a component in the machine shop. You are using vernier caliper or micrometer. I ask you to measure the diameter of the component or shaft. That is known as nominal size. That is known as nominal size or basic size. Basic size, nominal size or basic size. And next, while studying the whole basis system and shaft basis system, you understand the zero line. Zero line is the imaginary line which is coming on the zero line. This is the imaginary line which is coming in between the upper limit, lower limit, and upper deviation and lower deviation of the dimension. Upper deviation and lower deviation of the dimension. In between the upper deviation and lower deviation, there will be a imaginary line that is called zero line. You clearly understand while studying the whole basis system and shaft basis system. So here the upper deviation is represented by ES, uppercase, all of you observe here, ES, uppercase letter ES for hole, lowercase letter ES for shaft. In the same way, lower deviation, EI for hole and EI for shaft. You understand where you have to consider upper deviation and lower deviation while calculating the limits for the shaft and hole while solving the problem. And fundamental deviation, this is coming below the zero line. You can calculate the fundamental deviation. You have the equation for this. You have to substitute the values of upper limit, lower limit, and the dimension or diameter in the equation. From that, you can calculate the fundamental deviation that you understand while solving the problem. And allowance. See, allowance is the dimension, that is the maximum difference between the dimension. Maximum difference between the upper dimension and the lower dimension of the hole and the shaft. Hole and the shaft. Next, come to the point. Very, very important. You have three types of fits. Three types of fits. All of you seen, you have to fix the bearing in the end of the shaft, or all of you observe in this diagram, the key is inserted in the shaft in order to place the bearing in the end of the shaft. And next, one more shaft is placed inside the bushes. For this, good example is the shaft in the mixie. All of you seen, the vertical shaft is placed inside the jar. Inside the jar, there will be a brass bush. After that, there will be a stainless steel bush is present, or collar is present. Or you have to place the shaft inside the mixie jar, or suppose you may have the washing machine or wet grinder or grinding machine or floor mill. You have seen, already have seen. Here, the key is placed in the shaft. The dimensional difference between the shaft and the key is very, very important. That is, the fit is an assembly condition between hole and shaft. Remember, a fit is an assembly condition between hole and shaft. The hole, definition of hole, a feature engulfing the component. Say you have a casting, in that you have a hole. All of you observe here how to write the diagram of the hole using engineering metrology. All of you observe here, this is the hole and this is the shaft. The maximum difference between the diameter of the shaft and the hole is C, and the diameter of the shaft and the lower limit of the hole is C. All of you observe here, upper limit of the hole minus lower limit of the shaft. Lower limit of the hole minus upper limit of the shaft. Okay, one thing all of you remember, this is very, very important. If the shaft easily moves inside the hole, can you get the rigid or tight contact between the shaft and the casting? Say you have a casting, in that if you place the shaft in that casting, if the shaft passes through the casting hole easily, then you will get the tight fitting of the shaft in the hole of the casting. No, that is nothing but the clearance fit. That is clearance fit. All of you observe here, the definition of the clearance fit is diameter of the shaft which is less than the diameter of the hole. Remember, then clearance fit exists, then shaft easily moves inside the hole, then it is called clearance fit. This type of fit is used for placing of bushes in the arbor of the milling machine, or if you want to fix the pulley in the center of the shaft, then both the sides of the shaft, if you place the bushes, the diameter of the bush and the shaft is less. Shaft is easily moves inside the hole. Then it is called clearance fit. The name itself indicates clearance. Clearance means shaft easily moves inside the hole. Inside the hole. Then clearance fit exits. You can define like this: upper diameter of the shaft, which is less than the lower limit of the hole. You can define like this: upper limit of the shaft, which is less than the lower limit of the hole, and shaft easily moves inside the hole. Then this type of fit is called clearance fit. Clearance fit. All of you observe here for mechanical engineers. This is very, very important. Diameter of the shaft less than the diameter of the hole. Then shaft moves easily inside the hole. Then it is called clearance fit. Then it is called clearance fit. Then next one is interference fit. Interference fit. For this, good example is, all of you observe here, the placing the key in the shaft and fixing the bearing in the end of the shaft, or cutter in the milling machine. Then interference fit exists. In this case, the shaft diameter, all of you observe here, the shaft diameter, which is more than the diameter of the hole. All of you observe here, in case of clearance fit, what happens? The diameter of the shaft less than the diameter of the hole. But in case of interference fit, diameter of the shaft and diameter of the shaft, which is less than the diameter of the shaft, which is more than the diameter of the hole. Remember, diameter of the shaft, which is more than the diameter of the hole. For this, good example is fixing of bearing in the end of the shaft, or fixing the cutter in the center of the arbor of the milling machine, and fixing the keyway in the shaft. These three are very good example for interference fit. Here you require hammer blows. Remember, how do you fix the bearing in the end of the shaft? Do you use a metal hammer? Remember, in your lifetime, never use metal hammer for fixing of the bearing in the end of the shaft. You have to use wooden mallet, wooden hammer, or rubber mallet. Don't use metal hammer for fixing of the bearing in the end of the shaft. If you use metal hammer, which damage the surface of the balls as well as surface of the bearing and the shaft. For that reason, never use metal hammer for fixing of the bearing in the end of the shaft. You have to use wooden mallet, rubber mallet, or wooden piece for fixing of the bearing in the end of the shaft. The interference fit exists when diameter of the shaft is more than the diameter of the hole. Diameter of the hole. Then it is called interference fit. So this type of fit is very much essential for fixing of bearing, fixing of cutter, fixing of key in the shaft. So these three are very good example for interference fit. Next, come to the point. This type of fit exists, transition fit. Name itself indicates once the clearance fit exists, once the interference fit exists. Diameter of the shaft once less than the hole. The second time, diameter of the shaft which is more than the diameter of the hole. Then transition fit exists. So this type of fit is required for bearing pushers or couplings used for transmission of power from one place to the other place. Here in this example, you can observe here coupling rings speak out in making holes or couplings. Usually transmission of power from one place to the other place. You might have seen in some of the workplaces, some of the workshops, they use only one motor. From that motor, they transmit the power from one place to the other place by overhead shaft, and by having using pulleys and belt, they transfer the power from one place to the other place. Many of you gone to the floor mill. There they have more than 3 or 4 floor mills. They transmit the power from one place to the other place by using V-belt drive or flat belt drive. There, if you want to join the shaft, for that you have to use couplings. So that type of coupling require the transition fit. Once the diameter of the shaft is more than the diameter of the hole, once the diameter of the shaft which is less than the diameter of the hole. Please, all of you, write down the question. Write down the question. Write down the question. Explain briefly. Explain briefly. Explain briefly with the neat sketch. Explain briefly with neat sketches. System of fits. System of fits. For this question, first write the definition of fit. Fit is an assembly condition between hole and shaft. That's all. Fit is defined as an assembly condition between hole and shaft. Next, write down for all the 3 types of fits, you have to write the diagram. See here, you have a diagram here, shaft and hole, clearance fit, interference fit, transition fit. You have to clearly show the tolerance zone. Say the upper limit and the lower limit of the shaft and the upper limit and lower limit of the hole. You have to clearly show in the diagram. So if you write definition of fit, clearance fit, interference fit, and transition fit. So many question paper, you have a question on fit. For mechanical engineers, very, very important. If you go to any manufacturing industry for job interview, 100% sure they ask you the question, name the different types of fits. If the person is very well very well know the concepts of fits, tolerance and limits, then always he asks the question, the system of fits. For mechanical engineers, this is very, very important. Say if you take any competitive examination, 100% sure you have a question in the examination. That is clearance fit, transition fit, interference fit. Next, come to the point, interchangeability. Interchangeability. Many of you have two-wheeler, Honda Activa, Suzuki, Pulsar, KTM, Duke bike like this. After completion of your degree, suppose if you go to the Gulf country or America or Europe or Australia, if you take your two-wheeler, say for example, Pulsar bike, how do you start the pulsar bike. Is there any requirement of a spark plug? Is there any requirement of spark plug for starting of the engine? Yes. All of you say that the answer is yes. Say, if you take your pulsar bike to Australia, if you go to Melbourne for higher studies, if you take your bike to the Melbourne, if anything happens to the spark plug which is in the pulsar bike, then what you will do is the same type of spark plug is available in the Melbourne in Australia. What is your question? What is your answer? The same type of spark plug is available in Melbourne, Australia. If your answer is yes, then tell me, how do you get the spark plug in Australia? Remember, this is very, very important. This is very, very important. If you manufacture the component according to the international standard dimension, say the two companies manufacture the spark plug, one is Bosch, other one is something name is there. Only two companies in the world, they manufacture the spark plug. If they follow the standard dimension, then the company has the worldwide requirement of their components, worldwide requirement of components. So for that reason, while machining the bore required for placing the spark plug in the engine manufacturer, that is the pulsar bike, and the spark plug manufacturer follow the international concept of machining or international standard dimension for machining of engine, for placing of spark plug, and also manufacturing of a spark plug. If they follow the international standard dimension, then you can easily get the spark plug in Melbourne, Australia. That is known as interchangeability. That is interchangeability. Say one thing, if you have the mixie manufactured by Prestige and also other companies, the same company, they sell the mixies in America. You will get all the components in the America. That is known as, if they follow the international standard dimension for manufacturing, then they get the requirement of the component throughout the world. So that is known as interchangeability. That is also called as universal interchangeability. Universal, throughout the world, throughout the universe, you can have the requirement of your components in the world. That is known as universal interchangeability. Suppose in Shumaga, if you have problem with the pulsar bike, you will get all the components in Shumaga itself. That is known as local interchangeability. Local interchangeability. Next, come to the point, selective assembly. Say you have 100 casting and you have 100 shafts. In that casting, I ask the diameter of the shaft is 20 millimeter, and I ask you to drill 20 millimeter diameter hole in the 100 casting. Then you can pick any one shaft in the 100 pieces, and if you place that shaft in the casting hole in the 100 casting, any casting, then it is called selective assembly. Selective assembly. for this good example is, if you have 100 casting, in that casting you have a hole of 20 millimeter and you have a shaft of 20 millimeter diameter and the 200 millimeter length. You can place any one shaft in any one casting. That is known as selective assembly. That is known as selective assembly. Remember, for any machine tool or any engine or anything, if you get the components throughout the world which suitable for your machine tool or engine or anything, that is called interchangeability. That is called interchangeability. Throughout the world or throughout the universe, if you get the component for your machine tool or your engine or anything, that is called universal interchangeability. Suppose in the local, in Shumaga itself, if you get the components for your machine tool or your engine, that is called local interchangeability. And then next come to the point, selective assembly. Say you have 100 components, that you can match the components with the other component, then it is called selective assembly. For this good example is, if you have 100 casting, in that you have 20 diameter hole and you have 200 millimeter length, 20 diameter shaft, you can place any one shaft in the any one casting. That is called selective assembly. Please, all of you, write down the question. Please, all of you, write down the question. Write a note on interchangeability. Many question paper, you have this question. Write a note on interchangeability. Write a question. Write a note on interchangeability. For this question, write a minimum 1 page in your own sentence. Consider universal interchangeability, local interchangeability, and selective assembly. Write a note on interchangeability. Now, I stop at this stage and I will continue in the next class. Anyone? Nitin, unmute yourself and tell me. I understand little bit of Nitin.
Yes, sir.
Have you understand little bit of fits interchangeability?
Yes, sir.
Okay, thank you very much. And now let's stop at this stage and I will continue in the next class. And one more thing, all of you listen carefully. I have given notes to Dalawai Xerox near DVS Circle, opposite to the convent. Have seen, many of you have seen that Dalawai Xerox.
Yes, sir.
There the notes is available, 1 rupee per page. You have 29 pages notes. You can collect the notes in the Dalawai Xerox. Yesterday, I have submitted, I have given to the Dalawai Xerox. You can collect the notes. So this is very, very important. You can collect the notes in Dalawai Xerox. Okay, now I stop at this stage and I will continue in the next class.